think a unit rate is? What's a unit rate? What's a unit rate, Hadley?
It's kind of like a ratio.
It is very much like a ratio. Yes. We're doing it. Yeah, we're kind of like going back into ratio land, except a little bit deeper and a little bit farther than we went in 6th grade. So a unit rate is very much like a ratio. Let's say I spend $5 on 2 pounds of grapes. Okay? How much did I spend on 1 pound? And how do you figure that out? Hadley, how do I do this?
You divide $5 by 2, so just 5 by 2. And you would get 2.5, but in money that would be $2.50.
$2.50. Now, let's look at our units. This is dollars per pound. So $2.50 per pound. So how much do I spend for 1 pound? $2.50. So this is our unit rate. When we say unit rate, it means how much is it for 1? Sure, it's great that I got 2 pounds for $5, but how much is it for 1? This is especially helpful if you're comparing things like at 2 different stores. For example, give me a number that's between 1 and, oh, that's not 5.
7.
Let's pretend I spend $6. So this is, let's say that this is Ridley's.
And then Walmart.
And this one's Costco.
Oh, Costco.
$6 for 3 pounds. We want to know which one is the better deal, and it's kind of hard to compare that sometimes. Nixon, what did you want to share?
Well, I was going to say the answer, but I know I'm not supposed to say that.
So how would we do it? How would we set it up?
6 divided by 3.
6 divided by 3. So what is our cost per pound?
$2.
This one is $2 per pound.
That means
So
it's cheaper.
for $2, so Costco's cheaper for each one. So this is where I need to make a decision of, it costs more, but I get more, but it's cheaper for each pound. So do I need 3 pounds of strawberries, or grapes? It was grapes, wasn't it? Will my family eat 3 pounds of grapes, or will half of them go bad? But it's cheaper at Costco, but I get more, right? So that's what you have to, but this is unit rate, and it makes it easier to compare things. $2.50 a pound compared to $2 a pound. It's really easy to see. $5 for 2 pounds versus $6 for 3 pounds. It's a little, I mean, I can do that math in my head really quickly. It's a little bit harder to see. Yes, Hadley.
Are we ever gonna like do this, but and like have like an amount of people you have in like your family, and then like how much each person eats, and figure out like really which one you want to buy? We need the math for that.
Let's do it. Because we're learning about unit rate and constants of proportionality. Okay?
Can we do
So how much would you say one person is going to eat? We're going to have a picnic. How many grapes should we plan on per person for our picnic?
about 20 probably?
But we need weight because it's sold by weight. You don't buy individual grapes. I have no idea how many grapes I'm buying.
Grape is 0.10 pounds.
I don't think so. Actually, I don't know.
Yeah, I don't know. I'm
Computer!
estimating.
How much does a grape weigh in ounces? Computer? How much does a grape weigh in ounces?
An average grape weighs approximately 7 grams. Smaller grapes can weigh around 5 grams, while larger grapes can weigh around 11 grams.
Ounces. So it's 7. Wait, how many grams are in a pound? It's 7.
Well, we need to figure out how many grams are in an ounce. I don't remember. I think it's 30, but I could be wrong. If there's fluid ounces and there's grams and it's... Computer, how many grams are in 1 ounce? Computer, how many grams are in 1 ounce?
1 ounce is about 28.3 grams.
Oh, that's nice because 28 is evenly divisible by 7. So, times 1 ounce over 28 grams. So we have about 0.25 ounces per grape. Okay, so this is going to be a little bit of a complex problem, but we can do
16
this.
ounces is 1 pound.
16 ounces is 1 pound. We're going to get there. How many grapes per person should we estimate that we're going to be eating? Now remember, we're inviting you guys. We're inviting old people. It's like the whole big honkin' family reunion. So grandma's going to be there, aunts and uncles, cousins, everybody's going to be there. So how many should we estimate per person? 45 grapes per person? That is a lot of grapes.
Kinsley Stevens, please come to the office to check out. Kinsley Stevens.
That's not you. Okay. So if 1 grape is 0.25, I think that 15 grapes is actually reasonable. Except you know what let's do? Should we do 16 grapes?
Yes.
Why do I want to do 16 grapes?
So it's not.
Because it's not reasonable.
Well, because each grape is 1/4 of an ounce.
Yeah.
What's 1/4 times 16? 4.
Oh.
So everybody's having 4 ounces of grapes. Do you see why I wanted to do that?
But how many ounces are in a pound?
How many ounces are in a pound? You guys remember? Somebody said it. 16. There are 16 ounces in a pound. So everybody's having 0.25 pounds. So there's 0.25 pounds per person. Do you see how we have per un? Guess what? I'm in the dark zone and I can't spell. Okay. So it is 1/4 pound of grapes per person. That is our unit rate. How much will one person be eating? 1/4 of a pound, right? So how many people are going to be at this family reunion? How many people show up to your family reunions?
15. No.
Your family is small.
No. A lot more.
45.
Remember, we've got grandma, grandpa, and aunts and uncles and cousins.
Which side? My mom's side or my dad's?
77. Let me count that. 4.
54.
5. That's 9.
54.
36.
120.
Should we say?
Jared Keller, please come to the office to check out. Jared Keller.
I have 30.
I was gonna say 40. I think 40 is a decent average. I'm hearing some families are 60 and some families are 30. I think 40 is a decent average for these families. Now, are you gonna use different numbers for your family?
Yes.
Yes, you're gonna estimate. But we're gonna say, what if we have 4? So we're gonna use our constant of proportionality. We have 40 people times 0.25 pounds per person. How many pounds of grapes are we going to have? What's 40 times 1/4? What's 1/4 of 40?
Oh, it's 10.
10. So I'm going to need 10 pounds of grapes. Oh dear me, I have a problem. Do you guys see my problem? They're cheaper at Costco, but they only come in packages of 3 pounds at Costco.
You could just buy extra from Costco and it might cost like the same as
You could have extras in case somebody.
We could have extras. Somebody wants to have more, or you could have leftovers. Leftover grapes is not the end of the world. Or seconds. You might have that kid. You know that kid. That kid might be you, who sits there and goes. There's that kid at Thanksgiving who does that with the olives. So I'm sure that there's a kid who does that with the grapes. Do you know who I'm talking? She's laughing. Is it you? Is it you?
I'm the one that eats.
Okay, so Kinsley is the kid in her family. It might, like I said, it might be you. Yeah, Nixon. What were you gonna say?
I was going to say that you could get 2 of each.
I could get 2 of each.
Yeah.
I could get. Well, let's see.
6.
If I wanted to get enough for everybody, how many pounds would I need to get over here?
10.
10. I can't get 10 pounds. That's not an option for me.
12.
I would need to get 12 pounds. So I have $2 per pound. That's our unit rate. Times 12 pounds. So that's $24 on grapes.
Well, the only thing is if we get exactly the amount, like, what if somebody brings a friend, or what if somebody wants to eat?
You do want to have a little bit. You are not wrong. You want to have a little bit extra. So this is where we're deciding what we're going to do. Ridley's, we could get exactly 10. So we could say we're going to have 250 times 10, and we're going to spend $25 on grapes at Ridley's.
It's like a better deal it's just to buy more at the other.
And it's better deal to just buy more. So we're gonna buy them at Costco. We're gonna have, maybe we can send these families, that kid who's going whoop, 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 whoop. We'll send the leftover grapes with their mom. So when Kinsley comes to the barbecue at my house, we'll send them with her parents. Here you go, Mr. and Mrs. Larson, have some grapes for Kinsley. Yeah.
Wouldn't the one where you, because if we wanted it exact, wouldn't
That'd be
getting
10.
two of each be the cheapest?
What was that?
If we wanted it exact, wouldn't getting two of each be the cheapest? Getting two at Costco and two at Ridley's.
2 at Costco and 2 at Ridley's. So we have 2 times 6 and we have 2 times 5. So that's 12 plus 10. So yeah, it would be $22. So that would be the cheapest.
But you do kind of want it.
But I'm gonna be honest with you, the thought of going to 2 stores just for grapes makes me want to cry. I'm not gonna do that. Now you could. You've got your gas, although the gas to Costco is a heck of a lot more than the gas to Ridley's because it's in Pocatello and Ridley's is in Blackfoot, right?
But we're not gonna go.
We're not gonna go that far. So you have 3 choices. You could buy 2 of each like and get exact. You could just go to 1 store, or you could get some extras to send home with Kinsley and her family. Or I have a kid who does that, whoop, 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 or used to. But he doesn't live with us anymore, so we don't go through a lot of grapes. So I actually might do, actually, you know what I would do? I'd do this one, and then I'd give the leftover grapes to them. Guinea
All
pigs
of our
like
family
grapes.
does that with grapes.
Yeah.
It's like after we buy a huge pack.
Today I discovered the guinea pigs don't like raisins. I spilled a bunch of raisins on the floor, and I tried to give them to the guinea pigs, and they were like, "What is this?" And they wouldn't eat them, so I had to put them in the garbage because I didn't want them because I stepped on them. But Quincy was there. All right, so unit rate as a constant of proportionality. You guys totally saw how that just went down. Let's do one on your assignment together.
Number 1.
Number 1.
It's an essay.
Wildlife conservationists. Woo! That's a stretch from grapes, right? But that one actually, I love that Hadley wanted us to take it further because we could actually use like real math to figure out a real problem. And I don't know which one is the right one. You guys figure it out for yourselves. But anyway, wildlife conservationists are concerned that the deer population might not be constant across the national forest. Okay, question A right there. Why does it matter if the deer population is not constant? Why do we even care? Matthew, why do we care?
Because if it's not equal, then they would destroy and some predators might starve it all.
Well, okay. We usually they don't worry about predators starving, which is weird because we like the predators too. What do they worry about starving?
The deer.
The deer. What else do we worry about? Tallulah.
Poachers and stuff.
We worry about poachers. What else do we worry about?
Then going extinct.
The deer are not going to go extinct. I mean, they could. We're worried about that a little bit. We're also worried about what's happening with the grass. There's this thing called overgrazing. If they eat all the grass down to nothing, then you don't have any grass and the grass dies, then you've got just a bunch of bare dirt and you're at risk for landslides when it rains. Okay? So you don't want the deer to overgraze. You don't want the deer to starve. If all of your deer, these black dots are representations of deer, because I'm not even going to try to draw deer.
Kill Jensen, please come to the office to check out. Kill Jensen to the office.
So that's 1 deer?
No, those are all deer. We're looking at them from the sky, which is very far away. And then we've got this deer and this deer and this deer over here. And then
All the grass on like the most populated place.
what's happening to that grass?
Die.
It's gonna die. And then what happens after the deer eat all the grass? What are they gonna do?
They're gonna move.
They're gonna-
to the next.
They're gonna move and they're gonna overgraze, or they could die.
It looks like a
These
flower.
guys over here, now these guys are not as susceptible to predators because when they're together in a herd, they're not very susceptible to predators. These guys are. Little wolf pack over here. I'm gonna take them down. And then these guys over here are gonna overgraze and they're gonna run out of food.
Well, the only
Wolves aren't
thing
gonna get them.
If there's a wolf pack, they'll probably try and go for the bigger group.
No, they don't.
A lone little deer all by itself is a whole lot easier to get when he's not with his friends.
Yeah.
There is strength in those numbers. Because then the wolves can get confused and the deer are running anyway. This isn't National Geographic, but trust me.
Yeah, I've seen the National Geographic.
So we need to figure out what the population density is per square mile. So there was one area of the forest.
I did the math and it's 9.
We're not, just don't jump to the end. Are you the kid who reads the last page of the book first and then tells everybody how it ends? Don't do that. Okay. So this is 16 square miles and there are 144 deer. And then there was another area over here. It was oh, I did not draw that to scale even a little bit. And I know that the drawings say that they're not to scale, but I kind of try a little bit. This is 117 deer in 13 square miles. And this is bigger. So 216 deer in 24 square miles. And the question is, what is the population density in each of these? Nixon.
I was just saying, so A would be like, because.
Okay, tell me how you figure it out. Don't just spit out the answer.
No, I'm saying on A.
A, yeah, A is, there's overgrazing, there's predator issues, whatever you want to put down there. Yeah. So Gentry, how did you figure out, you already have the answer, and I know you already have the answer. How did you figure it out?
144 divided by 16.
Okay, so can we intelligently compare these? I'm good at math. Can I look at those and know if they're all the same? Not a clue, actually. Like I'm looking at this like, I don't know. So we're gonna divide. We're gonna figure out, we know there are 144 deer in 16 square miles. How many deer are there in 1 square mile? And Gentry says we're gonna divide 144 deer by 16 square miles. And what did we end up with? What did you get, Gentry? 9. He got 9 deer per square mile. So in every square mile, you would expect to find 9 deer. Okay, what about over here? How would we do that here? Same way, right? 117 divided 117 deer divided by 13 square miles. Who can math that for me?
My calculator can.
Oh my gosh, you guys, we can do
That's 9
this.
as well. That's 9.
Is it 9 as well?
Yeah, it's 9.
9 deer.
The next one is also 9.
Is the next one also 9?
Yeah.
And the next one is also 9 deer
Yeah, that one's 9.
per square mile. Okay, so they all have, so do we have a pretty much even population density in our national forest?
Yes.
Which is what we want, so yay. The unit rate of per deer per 1 square mile is how many are in 1 square mile? 9. Now we're going to use it as a constant of proportionality. So what if we have 209 square miles? How many deer would we have? Well, what's our constant of proportionality?
9.
So what do we do?
9 times 200.
9 times 209. So we would have 1,881 deer in 209 square miles. See how I did that? Could we figure out how many were in any amount of square miles?
1,000 square miles.
Well, oh, that math is easy. What's 1,000 times 9?
9,000.
9,000. We would expect to find 9,000 deer in 1,000 square miles. That's a lot of deer, but 1,000 square miles is also a lot of land.
What about 1,200?
You are welcome to do that math yourself. Okay, so now we're going to go backwards. How many square miles would we need to find 486 deer, and how would we do that? I just drew on my nose with my marker. I felt it. I have black on my nose? Oh, good, because it felt like I drew on my nose. Okay, so if we had 486 deer, well, if deer equals the rate times the area, can we use that formula? Because how many did we find out how many deer we had? We had the unit rate times the area. But now, we're gonna go backwards. How many deer are there?
Right times 486.
486. What's our unit rate? How many deer per square mile?
9.
Can we figure out how many are there?
Yes.
Does this look similar to what we did a little bit ago?
Yeah.
How do we figure out how many deer there are? Or how big of an area it is?
So we
I'm gonna divide both sides by 9. 9 goes into 486. 9 goes into 48 how many times?
5 times.
5. And then we have 36. 9 goes into 36 how many times?
4.
So how many square miles would we need to have 486 deer?
54.
54 square miles. See how that works?
Yeah.
So we can go forwards and we can go backwards. So let's look at independent and dependent variables. That's not part of this assignment, but I want to reinforce it. Which one's the independent variable? Is it deer or is it area? How many deer do we have?
9. Oh, 9. It's
No, we don't know that we have 9. How many deer do we have?
depends on the.
Depends on the size of the area. So which one's dependent? Dependent. And which one's independent?
Because because the land is just there.
The reason I wanted to do that is the dependent variable always equals the rate multiplied by the independent variable. So when you're setting up these equations, you can remember that. The dependent variable, which I didn't make it D for dependent, I made it D for deer, but that was sure convenient, equals the unit rate times the independent variable, which in this case is area. Tallulah, it looks like you're gonna like launch out of your chair.
So what's the constant of proportionality?
What is the constant? It's our unit rate. It's what we're multiplying by. It's 9. It's our unit rate. How much is it for 1? And then you know if you have 20 square miles, how many deer are you gonna have? What's 20 times 9?
No.
It's 180. We're gonna have 180
the
deer.
office to check out.
Right.
Carson Heiner.
So our constant of proportionality is 9, and then we can set up this equation, which we're going to work on more tomorrow, and then we can go backwards from it. All right, you can say if I have 486, if I have 900 deer, how many square miles would I need for that? 100. How did you do that, Hadley? 900 divided by 9. If I have 9 million deer, how many square miles am I going to need to have? 1 million square miles. Am I probably going to have this?
No.
Probably not. But if I did, I would, right?
Wait, does the Earth have 1 million square
Oh,
miles?
buddy, the Earth has much, much more than 1 million square miles.
1 billion?
I don't know. I'd have to sit down and math that. I could, but I would have
Or you
to.
could just ask.
I could look at it. Well, let's turn off the video and then we'll math